Welcome to this exam prep explainer. If you are gearing up for the Nutanix Certified Professional Multi-Cloud Infrastructure or NCP-MCI 7.5 certification, well, you are in exactly the right place. Today, we are focusing heavily on a very specific, absolutely crucial area. We're going to cover NCP-MCI 7.5 2.4 Right-sizing Prism Central for enabled features. As an infrastructure admin, you already know that flipping the switch on a shiny new feature is the easy part, right? But making sure your management plane can actually handle that new load, that takes precision. We are going to break down exactly what you need to know to absolutely crush Objective 2.4, ensuring you understand the underlying architecture and the strict rules Nutanix enforces.
Here is our game plan for today, structured specifically to get you exam ready. We're going to look at why right-sizing matters, walk through some concrete examples, tackle those sneaky common exam traps, and lock down the key facts you've got to memorize.
All right, part one. Let's talk about why right-sizing actually matters. Before we even think about doing the math on RAM, we have to understand the stakes here. Prism Central, or PC for short, is basically your central nervous system, and Nutanix has hard-coded checks to protect it. The primary safeguard you need to know is the test_prism_central_resource check. This is a strict, non-negotiable pre-upgrade check. If you try to upgrade your software or enable heavy services like self-service, which you might remember as Calm, or Intelligent Ops, formerly AI Ops, without provisioning enough resources first, this check is going to stop you dead in your tracks. For the exam, you need to recognize this exact string. It acts as a gatekeeper, comparing your current CPU and memory against a strict matrix of required resources for whatever feature you're trying to spin up. Now, on the flip side, for ongoing monitoring, we have the Nutanix Cluster Check, or NCC. NCC constantly runs check ID 20327 to make sure your PC VM isn't starving for resources. This is specifically called the PC VM Resource Resize Check. So, while the previous check is your gatekeeper during an upgrade, this NCC check is your everyday dashboard warning. If your current features demand more resources, say you've expanded your environment, this check is going to flag a failure, letting you know your memory and virtual CPU, or vCPU, are inadequate for your small, large, or X-large PC variant. And check this out. This is what a hard failure actually looks like in the real world. See that red text? It's explicitly warning the admin that the memory on the Prism Central node is sitting at 26 gigs, which is under the required 28 gigs, and the CPUs are at 6, falling short of the required 10. The upgrade literally cannot proceed. Trust me, as an infrastructure admin, you do not want to be staring at this error during a tight maintenance window. You want to know those sizing requirements way ahead of time.
Moving right along to Section 2, let's walk through some concrete examples of how this all works. Let's put this into practice with some real-world math. Example 1 on the exam almost always revolves around scaling your disaster recovery. So imagine you're setting up disaster recovery as a service, DRaaS, and your environment is booming. You're protecting a massive number of virtual machines and volume groups. At what exact point does Prism Central finally say, hey, I need more power? And exactly how much power does it actually need? The absolute crucial point here for your exam is the threshold. The very moment you cross 2,000 protected entities, you enter what's called DR scale. When you hit this threshold, you must add 2 gigabytes of RAM and 1 vCPU core per Prism Central node. And I really want to emphasize that per node part. If you're running a scale-out Prism Central deployment with 3 VMs, you are adding those resources to each of the 3 VMs, not just one. Why? Because managing the metadata and replication schedules for over 2,000 entities puts a massive baseline load on the PC database and its background services. Now for example 2, which focuses on feature combinations, and this is a huge trap on the exam. Let's compare these capabilities directly. A small Prism Central simply cannot, under any circumstances, run intelligent operations alongside self-service or DRaaS. The machine learning algorithms for intelligent ops, combined with the automation of self-service or the replication engines of DRaaS, it will completely overwhelm a small PC. If you need that specific combo, you have to scale up your base Prism Central VM to the large variant. The exam will definitely try to trick you by asking how much memory to add to a small PC for this combo. The correct answer? You don't add memory, you convert to a large PC entirely.
But here's the cool part about how Nutanix handles this. When combinations are actually supported, the system is very smart about resource pooling. Because features like disaster recovery and self-service share common underlying microservices and database resources within Prism Central, you don't get hit with a double penalty. For instance, enabling DR on a small cluster typically requires a hot add of 4 gigabytes of memory. If you then enable self-service, it doesn't jump to 8 gigabytes, it just stays at that initial 4 gigabyte addition. Understanding this shared resource model is an absolute must for accurate infrastructure planning.
All right, Section 3. Let's talk about those common exam traps you need to dodge.
Because knowing how much RAM to add is only half the battle, right? Knowing the strict operational procedures is where candidates usually drop points. If you're operating a scale-out Prism Central, meaning a 3-node cluster, you absolutely must follow this sequence. First, you power off and resize one VM at a time. Never, ever power down the whole PC cluster simultaneously for a resize. Second, you cannot update memory and CPU in the same action. You have to update the memory allocation first, save it, and then update the CPU allocation separately. This is a strict hypervisor and management engine update sequence requirement.
Here is your strict never do this edge case list. Commit this to memory. First, never rely on vCPU hot add for these specific sizing upgrades. Always do a clean power cycle for base resource changes. Second, if you're logged into a scale-out PC node, never run the standard Linux command shutdown hnow. It will wreak havoc on cluster services. You have to use cvm shutdown pnow or properly stop the services first. Third, like we just said, never update memory and CPU simultaneously. And lastly, never use the standard UI to decrease memory if you're running Nutanix AHV hypervisor.
I want to drill into that last point because it is a textbook exam gotcha. Say you over-provisioned your Prism Central memory on an AHV cluster, and you want to pull some of it back. If you power off the PC VM, go into the Prism Element UI and try to lower that memory slider, it's going to explicitly fail. The UI is designed to protect the VM from accidental memory starvation. To actually reduce the memory, you are completely forced to use the Acropolis Command Line Interface, or ACLI, from a controller VM, also known as a CVM. You literally have to type out ACLI vm.update, followed by the PC VM name, and then memory equals whatever size you need in gigabytes. Write that command down. Okay, Section 4, the absolute key facts to memorize before test day.
Let's do a rapid-fire review to lock this all in. First number, 200327. This is the exact Nutanix cluster check ID for the PCVM resource resize check. If a question asks which check ID validates Prism Central VM resource adequacy, you are looking for 200327.
Next up is 2000. This is the hard threshold of protected entities where DR scale officially kicks in. If you have 2001 virtual machines protected, boom, you are in DR scale territory and you must provision that extra 2 gigs of RAM and 1 vCPU per node. Take a mental snapshot of this checklist right here. Remember the small PC limits. It just can't handle combining intelligent ops with self-service or DRaaS. You must go large. Remember the strict separation of memory and CPU updates. Do them one at a time. Always resize scale-out VMs sequentially, one by one. And finally, remember that ACLI requirement for HV memory reduction. Knowing these limits isn't just about passing the NCP-MCI 7.5 exam, it literally protects your real-world infrastructure from completely preventable outages and blocked upgrades. So I'll leave you with this. Looking at your own environments today, are you confident your Prism Central is right-sized and ready to survive its next pre-upgrade resource check? Thank you so much for joining me for this explainer. Keep studying hard, and I will catch you in the next one.